Hey guys, this video will be about the pop-up headlights of the 5th gen Celica, more specifically the retractable mechanism and the controller which controls the headlights. So let's take a closer look at the mechanism itself. The two motors on the left are completely unrelated, so ignore those. So this is the actual mechanism. Here is the bucket seat for the headlight. And here is an aftermarket LED headlight I tried to fit in there, but didn't quite fit, and I'll show you why in the next image. Taking a closer look at the headlight bucket seat, you can see it's in the shape of a cone. The factory headlight, which you can see highlighted here, can fit in here just fine. But the aftermarket headlight I bought that's intended for a Jeep, which you can see here on the left, is much more wider and had a really hard time fitting there. I tried trimming off some of the fins on the back, but ultimately I was not able to fit it. Now that doesn't mean that you cannot fit any aftermarket LED headlights in there. I successfully acquired another set which fit. That's probably for another video though. Just make sure that before you buy any aftermarket headlights, check to see how they look from the back, and if they are white like this one I bought, then try to acquire another set which seems more cone shaped in the back. That's much more likely to fit. Getting back to the retractable mechanism itself, let's inspect it in more detail. So here is the electric motor, here is the connector for the motor, and here's the shaft. The motor spins around continuously, and this shaft transforms its movement into moving the headlight up and down. This is how the headlight looks retracted. And here it is, back again in the up position. You can actually move the headlight using its little knob at the bottom, as you can see here. It takes a lot of time, but you can manually retract or pop up the headlight. I will move it around so you can better see how the shaft adjusts or transforms the motor's rotation into moving the headlight. And here we can actually hit the end stop. As you can see, here is the bottom end stop for the down position. Something similar is also for the up position. I imagine this can be adjusted, but I've never had the need to do so. I will now move the motor with my 12-volt power supply. I have the negative pin hooked up, and when I touch it with the positive one, you can see it moving. And as you can see, this motor has no reverse. It just keeps cycling up and down. Basically, the mechanism is quite ingenious, so there's no need to have any sort of reverse feature. In order for the controller to control the motors, it needs to have some feedback about the motor's positions. In Celica, this is done through a switch which is mounted directly onto the output shaft of the motor. The cover of the switch is held on by two screws, which I'm taking apart right now. With the cover removed, you can see the contact plates and the contact disc. The white spot here and there is the up and down position. Let's take a look at the switch in action. I have the negative pin hooked up to my supply, and when I touch the positive pin, you can see the contact plate spinning along with the motor. The plates on the other side are fixed in place. I will demonstrate how this switch works with an LED. I have an LED with the resistor connected to the input of the switch, and I have grounded one of the switch outputs. Now, if I manually retract the motor, you can see that once I reach the down position, the LED has turned off. If I move it back, it turns on, and so forth. So basically right now, the LED will stay lit as long as I'm not in the down position. But if I reach the down position, it will turn off. I have just switched the wires to the other output. Now the LED will stay lit on until I reach the up position. As you can see, the LED has turned off. Now let's take a look at the wiring diagram. Light Retractor Relay is responsible for controlling the headlight's movement on the Celica. The left side of the schematics are the inputs. B3 is the power. It is fused with the RTR fuse. B8 is the up input. So if you flash your headlights or turn them on, this input will get grounded. B6 is the pause input. If you put your light switch into the pause position, this input will be grounded as well. For easier understanding, I have highlighted the positive wires that have 12 volts from the battery in red, and the grounded wires with blue. So hopefully this makes the input side a bit more understandable. Also, the output side has been highlighted a bit as well. Basically, the switches with B2 and B5 have constant 12 volts on them, and the motors are just grounded all the time. Oh, and the connector for the Light Retractor Relay is the connector B, at least from my experience. If you have a different connector, let me know, but from what I know, all the T18 Celicas should have this connector. After some digging online, I have acquired a more detailed schematic of the controller itself, the Light Retractor Relay, I mean. So the Light Retractor Relay on this schematic is highlighted in green, so basically everything inside the green box is inside the Light Retractor Relay, and I have also highlighted the individual motor assemblies in the blue, which contain the motor and the switch wiring. Once again, I have highlighted the positive wires with red and the grounded wires with blue. The motors and the switches are located in the up position in the example of this schematic. There is two very important transistors which control the headlight movement. I have highlighted those with a green circle. One of them makes the headlights go to the down position and the other one makes them go to the up position. Normally both of these transistors are not active, but if you activate one, that's where the headlights will go. If you activate both of them and keep them active, they will cycle indefinitely. I have created an example where I activated the down transistor to make the headlights go down. In this case, the current would flow through the green highlighted wires with arrows pointing in which direction the current would go. So it would start at the B3 at the input and go through the first transistor, which honestly I have no idea why it's there, it seems to be powered at all times. And then it would go through the coils. There are two relays inside here, each controls the individual headlight, and the current would flow through the coils of these both relays. Then through these coils it would head into the switches, and finally it would go through the switches to the down transistor which I activated and to the ground. When the coils are grounded, they will activate their respective relays, making their motors start spinning. One more important thing to note here is the diodes at the output of the switches. These ensure that each motor can operate independently. So let's say one of your motors is slower, or for example one is at the up position and the other is somewhere in between for whatever reason. Activating the down transistor will make both of them reach the down position. Even if one arrives, let's say, half a second earlier, the second one will still continue moving until it has reached the desired position. Let's take a look and see what you can actually do with this information. So I've been working on my own custom controller for a while. It would be a direct replacement, plug and play, with the option of connecting extra buttons for doing the sort of wink. So let me show you some individual headlight control here. And that's all for this video. If you have some more questions about how the controls work or how to control your headlights, let me know in the comments, I'll try to help. And when I finally finish my control, I'll make another video. I'm thinking maybe around 60 bucks would be the price for it, but yeah, let's wait for that video and so you can see all the features. Well, see you next time.